Okay, let's take care of some sparks. These sparks are actually kind of codependent on the electric arches. So I'm gonna do everything on the same one, on the same node. So dev electric arches and sparks, just so it's clear that everything is in here. Now, I'm gonna go back to the using the time shift. It'll make things easier for us to be able to actually visualize what's happening. Okay, because we do have the static mesh. Okay, next, we don't want sparks to be generated all the time. And the way we can do that, the way we can control that is if we have some attribute on the surface that kind of controls areas where we should have sparks in case an electric arch passes by, and areas where even if the electric arch passes by, it's not going to be generating sparks, something like that. So I'm going to use an attribute noise on the surface, and I'm going to call this sparks mask. Let's have a look at it. It's not a vector, it's a float, and let's call it sparks mask. Let's have a look at it. Okay, there we have it. Right click. We don't need this one, sparks mask. I'm going to change the color, white to red, min and max 01 sounds great. And here, I don't want it to be animated. I don't want that pattern to be changing over time. I do, for that purpose, we should remember that the location attribute should be rest, just so it doesn't change over time, okay? So this way, if we go to the time shift and we change something here, or if we connect this here, you'll see that the pattern is sticking to the character. Awesome. Now we have the sparks mask. Let's make this a bit more interesting. The element size should be smaller, 0.1. Why not? Yeah, I think this should be good enough. And now that we have that mask, we can actually hide it. We don't need it anymore. And we're gonna be grabbing these points. So we merge points on this merge points. And this is what we're going to be adding. So we have our points here, barely visible, but they're there. And I'm going to go and do a point wrangle on those points. Those points are going to be the source of the sparks. And we're going to be checking if those points are going through an area that should generate sparks. That's the main thing. Sparks mask is going to be equal to the point. Again, we need the closest point. Okay, we always need the nearest point. So let's int ref point is going to be equal to near point on 1 based on my position. Okay, this is something that we're always using. It's so useful. Float, add sparks mask, and let's check what's the value here. So let's say point with an I. 1 sparks mask. What's the value of this, Mr. Ref BT? Okay, so we have the sparks mask. And now we're actually going to be removing all the points that don't meet a certain threshold on the refs on the sparks mask. So let's say blast. I want to make them more visible, so I'm going to go here, visualize geometry, points, let's say points, and let's exaggerate this to 5 so that we can see them a bit better, for God's sake. So here we have much bigger. Now we can see them. Go to blast. It's going to be points, and we want to blast everything that's below sparks. Sparks mask below 0.5. So everything that's below 0.5 doesn't count. This may still be too many, so let's 0.6. So only the points that are going through a surface, part of the surface of the robot that has a high value of sparks mask will be considered as emitters of the sparks. Great. So now that we have that, we're going to be using a pyroscatter from burst. This will be the source. Now, we need to adjust these parameters quite a bit. The default values aren't really taking into account the scale of our scene. Let's keep the robot visible. Not this one. Let's keep this one kind of visible. Okay. So as you can see, these are all over the place. We don't really want that. So let's go with the burst shape first. So initial size, I just want the points. I don't actually need some shape or anything. Let's go 0.01. It's probably still too much, but we have them there. Let's actually increase the size so you can understand what's happening. Notice that they're all just pointing up. Not cool. We need them to align to the normal of the surface. Okay, so let's grab that normal. We can probably add them here, but let's just add them here. Why not? So let's say that the vector normal of my point is going to be equal to the normal of the near point. Ref pt. So now we should have normals on these points, but we don't because we're missing normals here. So let's connect them here. Okay, wonderful. So now that our points have normals, on our pyroscatter from burst, we can say that the direction is based on an attribute, and it reads the normal attribute. Awesome. Now let's bring this to 0.01. These again are just going to be seeds for points. What else do we need? We want some around 20. Let's set varying. So we have 20 plus 10 plus or minus 10, a variation. Let's go to the output direction, velocity scale. Let's go with 1. It was too big, 24 for sure. And I guess that's pretty much it.